For this application, we have an airplane is flying with an airspeed of 310 knots on a heading of 050 degrees. If a 78 knot wind is blowing from a true heading of 125 degrees, determine the speed and direction of the plane relative to the ground. So let's go ahead and draw this picture out first. So we're going to start with our north-south line. And then our plane is flying. It's got a magnitude of 310. And the angle here is 50 degrees. Now let's draw the next vector. The wind is blowing at an angle of 120, or the bearing or heading is 125 degrees. So we're going to start with our north-south line. 120 would be somewhere over here, and it's 78. So let's make that one just a little bit smaller, because if this is 310, 78 is going to be much smaller. And I'll go ahead and write in that big angle here is 125. So now what we want to do is we want to determine the speed and direction of the plane relative to the ground. So the result of both the wind and the speed of the plane. So we want to put these two together. So what I'm going to do is I'm going to go ahead and just duplicate this. Actually, let's just duplicate the vector parts. And what we're going to do is we're going to find the resultant of these two vectors. So I'm going to take this vector here and I'm going to put it right there. So the resultant, we'll use a different color. Let's use green. Remember, green, the resultant starts from the bottom here and to the tip here. There's my resultant. So what we want to find is this green angle right here, and this magnitude here. Let's call it x. This is perfect because we have some formulas for non-right triangles. Remember, we learned law of sines and law of cosines. We can apply law of sines and law of cosines here to find these missing values. So first, we need to know what is the missing value here. Well, this angle here. So that's just the angle between the vectors, the blue vector and the red vector. So let's go back to our original diagram. The angle between the blue vector and the red vector is going to be 125 minus 50. So I know that this angle here is 75 degrees. We just subtract those two. Now we know the red vector is 78, and we know the blue vector is 310. We can apply our law of cosines to find out what this measurement x is. So let's do that. X squared equals 310 squared plus 78 squared minus 2 times 310 times 78 times cosine 75. This is the law of cosines. Make sure your calculator is in degrees when you calculate this. And then we take the square root because this is x squared, and you should get 299.4. So now I know that this x value, the magnitude, which is our speed, is 299.4, and it's knots. all we have left is to find that angle. So let's find this missing angle here. We know that this whole angle is 50. So what we need to do is find this little angle right here and then just subtract it from 50. That'll give me this missing part here. So we're going to use our law of sines. Because now I know the side opposite of my angle, we found that here, we can use the law of sines. The law of sines will say that this side, x, which is 299.4 over sine 75, equals the side opposite this one, which is 78, over sine, I'm going to call it A because I don't know what it is. Cross multiply. Divide. And then we have to use our inverse sign on the calculator to find this part. And this gives me A equals 14.57. So if we're going to round to the nearest whole angle, that would be A equals 15 degrees. So now that I know A is 15 degrees, all I have to do is write 50 minus 15, which will give me my final value. So 50 minus 15 will give us 35. So this plane has a speed of 299.4 knots and a direction of 0, 35 degrees.